second session, as you may know, is entitled Fostering Transatlantic Growth of Marine Renewables.
Well, thank you very much, Manuel, for the introduction. Well, what I intend to speak about today is, in particular for our American guests, is a bit of what has been marine renewable energy in Portugal. And the first topic that I would say is it makes sense because of a number of conditions that exist in our coasts. With respect to the size of Portugal, we have a very long coast, and we have a good resource in the sense both for wave and wind, not the best resource, but a good resource because it contains energy and it has associated with it very good meteorological conditions that allow you to go offshore with much more frequently than in many other places in the world. And that is important for the early stage of the development of these technologies. Then we have also a very well infrastructured coastline, not only in terms of grid connection. Most of the population lives along the coast in 20, 30 kilometers onshore. So we have a very good onshore grid, electrical grid. And we have a number of harbors and shipyards along the coast. So it's a very well infrastructured grid. And furthermore, we have very high potential of delivering energy at the national scale. Of course, from time to time, we have also very big storms. This is a very big wave, not far away from Lisbon, that was served by McNamara, an American, 2 years ago or last year or so. But let me tell you a little bit about how we develop marine renewable energy in Portugal. This was not a very structured plan, but in a way it was a plan. And it can be now, looking into the past, we group this along 4 axes. One axis is related to capacity building. And everything started in '78 at IST, R&D work that was led by, and is still led by, my colleague António Falcão, who was also my supervisor, PhD supervisor, and who is here in the audience. And then we start building some infrastructures. The first one was the PICO plant, OWC plant, the wave energy plant in the Azores. And secondly, or later, the setting up of an offshore test station, the Aguçadora test station, where a number of different devices have been tested, and also the setting up of WavEC in 2003. And by doing this, we also start developing a supply chain. I will show you a number of projects that has been taking place in Portugal with several logos, and we will see that some of those logos repeat, but there is at least, I don't know, around 10, 20 different companies involved in this project over the years. Then we have also built a legislation axle. I think we were the first country in Europe and possibly the world in setting up a feed-in tariff for wave energy around the year 2000. We set up the pilot zone that was just mentioned before. We developed a target for marine renewable energy for 2020. We started the maritime special planning legislation, and also at European level we have been involved in legislation, and we are now involved in the Ocean Energy Forum. Then the third axis was the attraction of projects to Portugal. But basically Portuguese projects that allow to develop prototypes to be tested here. And we will go through that in the presentation. And first and last but not least, we have been putting a lot of effort in the internationalization, not only in terms of Europe, but also worldwide. And in terms of Europe, we have been working a lot within the European Commission. Most of our funding comes from the European Union, and we have been clearly in excess of 30 different European projects over the last 10 years. We lead, we were one of the three countries that created the ocean energy systems, which is the implementing agreement for ocean energy within the International Energy Agency. And we are still very much involved, as WavEC is the secretary, or gives the secretary of this implementing agreement. We were co-founders, and we are still a member of the board of the Ocean Energy Europe, the European Association on Ocean Energy. And as you will see, we render services everywhere in the world. Furthermore, we have been deeply involved in KIC InnoEnergy. KIC InnoEnergy is the new engine for innovation in Europe, and we have been very active in the marine renewable energy sector. So, one of the first infrastructures that was created in Europe as a demonstration plant was the PICO plant, which you can see here, the noise from the turbine. The plant is still in operation after 15 years of existence, which is a landmark. And you can see here a number of logos of different companies in Portugal involved in this project. Then the second infrastructure was the pilot zone, but this was already mentioned in the first presentation, so I will skip. Then the second or the first offshore project was between 2001 and 2007, with a very significant involvement of WavEC, but also other, sorry, it's running too fast. Yeah, here. So this is a Dutch technology that was partially built here in Portugal and tested here. Also, again, with a number of companies involved. Then also a project that was developed, but not built, unfortunately, that was an oscillating water column wave energy technology system at the Foz do Douro breakwater in Porto, again with a number of Portuguese companies involved. Then in 2008, the first world farm of wave energy with 3 Pelemas units built and tested over a few months. Again, the pilot zone. And more recently, two technologies have been developed in Portugal, one by Marty Fair. This project was fully developed, but not to the point of getting into the water, because it was basically in the initial phase of the international financial crisis, when money becomes much more expensive, so the project was aborted. But we could see here a more recent project developed by IST. Sorry, the code should be here. This is technology being developed at IST and tested in the UK at a relatively large scale. You can see that we can focus, or you can design these systems to have very big oscillations, much bigger than the waves. Here it's another technology, Finnish technology, AW Energy, that has been tested in Portugal since 2010, and that this year, very recently, won the new Interest Reserve 300 project, a 5-megawatt project funded through the European Commission to be developed here in Portugal. These are submerged plates, so similar to Bill's technology, but here they produce directly energy to the coast. So this project is still ongoing. It's on the water and working. And of course, later on in 2011, the wind float prototype developed by EDP with PPI, but also involving a number of Portuguese companies in the project. So this is also a very successful project, and together they also won the NER 325 megawatt project that was described a while ago by João Mansmet. And finally, we have been working on also on the supply chain, so building an industry roadmap, also with a number of Portuguese companies and organizations to deliver this industry roadmap also to identify who are the companies that are better prepared to step in this new industry. So let me now give you a few words about WavEC. WavEC is a private non-for-profit company. I'm sorry, I have to drink some water. I'm sorry. But, so this is a private non-for-profit company. And when I meant private is because we don't have any public support from the government, so it's fully competitive. And we are mainly devoted to wave energy and offshore wind, but we also cover other sources of renewable energy in the sea. And we are, in a way, a center of excellence, a center for consultancy, but also we are, say, a trade union, a trade association, as we are an association involving a number of partners from energy sector, research institutions, and engineering companies and developers. This is the list of projects that we have been running over the last few years. I can see that majority are European-funded projects, but some national-funded projects also. And these projects cover a wide range of different work. I will give you some examples. We have a training. Oceanet should be, it's missing here. Well, Oceanet is a training network at European level. We have also several projects related to prototype testing in the water, like Waveport, the demo float. We have a project which is a network of research infrastructures. This one here that concerns the development of multi-purpose offshore platforms. So we cover areas from technology, environmental impact, public policies, economic issues, supply chain, logistics, etc., etc. This is the list, or a map showing our clients spread all over the world, of course with higher percentage in Portugal and in Spain, but a bit elsewhere in Europe, but also in America, North, Central and South, Australia and Korea. And as I said before, we are completely private. We are funded 6% from our associates, almost 70% by R&D projects, most of which are European-funded projects, and about 24%, 25% from services that we render to companies. And this is a list of several work or several services that we have been rendering. Last year, we worked with the Costa Rica utility to do the marine resource assessment in the country. We worked with the Chile Ministry of Energy to provide a vision for marine energy in Chile and also help them to develop the tenders for two demo plants, one of wave and another of tidal. We worked previously with the Scottish Government in setting up the Saltire Prize for marine energy. And we have been working with Portuguese government in setting up the legislation for the pilot zone. And we have been working also with companies doing strategic analysis in terms of technology and market development. Examples are Gas Natural Fenosa from Spain, Iberdrola from Spain, or ADP and Galp from Portugal, and providing technical support, mainly due diligences, concept development, cost and economic models, numerical and experimental simulation, and field work. So all that type of work we do. So in conclusion, I can say that Portugal has a very significant experience in wave energy and also offshore wind. We have a wide cluster of companies in these two sectors, and we can offer an investment opportunity because of the conditions in our coast, but also we can offer now WavEC in Portugal strategic support, technological support, and we can do that ourselves, WavEC, but also with our associates, which are at present, as I said before, 12 companies and 4 R&D institutions. Thank you very much.
Thank you very much, António.
Thank you for the introduction. Thank you for the invitation to WavEC, and really these kind of initiatives are very, very important to make these efforts go through. Just by starting, we are a company that we are manufacturers, and we manufacture synthetic and fiber mooring ropes and also steel wire ropes. Among that, inside of our group, we have the engineering family of products, and we do engineer all of them. These companies, our expertise and why are we here presently is because we are the leaders in mooring systems, in synthetic mooring systems for the oil and gas worldwide. The company is a worldwide company. What we are seeing here is from Royal Lankhorst Euronet, which is a joint venture between companies from Portugal and Netherlands, and which was acquired by this American group, Wireco World Group, that started as a steel wire rope manufacturer in the United States, and then it went through acquiring other companies to develop a group to be on the family of the mooring solutions for all sorts of environments, and renewable energy is one of them. The idea here present is that we are having this group have a large experience, and we only speak about the section or the embedded area for renewable energy. On this presentation, the idea was to make a little bit everybody knows about our company, but then we will go focus to the renewable energy challenges and what was our past, because we have our previous experience, and how to arrive to the next challenge, insert on this logistical area. At the end, we will make a brief conclusion. So the company, as I explained, the American company, it's an hedge fund, a private hedge fund, American one, owned by Payne & Partners, which started with a company of a steel wire rope, and that gradually started acquiring steel focus on the steel wire sector, until 2005 and 2007, when in the offshore, when the platforms and the oil and resources like gas and oil start to be only present deeper and deeper, the only idea and the only concept that could be moor those huge platforms, it was to use a synthetical rope, because the steel wire ropes are limited to their to a water depth of around 1,200 meters. In Brazil, they were already at 1,800. In Norway, we are in shallow waters in this family, so the trigger was how to replace. So this group starts to change the trigger of companies that they have and try to move away, keep on, of course, the steel wire and going to the new areas of the synthetical fibers to moor all these deep water new facilities. The company itself, as this slide quickly tries to make understand, is it has a lot of companies since the steel wire rope family. So we start with American one, which is the Union. Then we have European from Kazar, and also Oliveira and Lankhorst in Portugal and Netherlands, and here in Poland. The synthetical family of products, which has a characteristic that all the manufacturing units are in Portugal, it's taking all the three brands that are manufactured back in Portugal. Another industry that was referred also important for the renewable energy, it's the electromechanical cables. This one is like a steel wire rope or an armor of wires that can protect the electrical signals, conductors that need to control the subsea installation equipment. That one we have as Gamesa and Wireworks that are in Mexico and the United States. This is just to produce to ourselves, so it's for the steel wire rope components. And the European section arm, which is the engineering products, which is where we develop the solutions for the synthetical products and also the flotation products. We have a wide global manufacturing footprint. We have 25 factories worldwide, being the majority in America. So we have 7 plants in America, 1 in Brazil, 2 in Mexico. The second big arm is in fact in Europe, where we have the synthetic ones together in the Netherlands. The rest of the group is mainly for steel wire rope. In Asia, we are present, yes, with the joint ventures, because we need to accommodate also for some areas that we need to take care about the growth of those enormous markets. Just to highlight it and to end the presentation of the company, we have a capacity globally and by year to produce and manufacture 4,000 and 8,000 tons of steel wire rope components, and roughly 330 joining together ropes and engineering products. We are 5 million employees on the group, and we aim to close this year with yearly sales of nearly $1 billion. So, this is just making an introduction about the company. Let's now be focused to where we are. My area where I work, it's on deep water mooring systems, and where we started since 1998 probably, it's where the oil companies and oil operators starting to have fields that are have to be developed at water depths of higher than 1,200 meters. So if we are beyond that figure, we cannot, it's very, very difficult to use the metallical components as it used to be. Why is that? Because the lines have to be so long that their own weight of the steel is consuming all the strength that the steel has. So you cannot be supporting any platform, any movement, any dynamical behavior. So where we have entered, we have already to assess and design mooring components that were primarily used in maritime normal business, and then we have to scale down together with the classification societies and the legislation and the bodies that control the environment of the sea to see what we can do to develop this type of special and tailor-made ropes for these mooring systems. What have we done? We started with the biggest player on this field, on the synthetic. I'm not speaking about the biggest company. So it's Petrobras started the idea of using polyester mooring ropes instead of steel wire ropes. And that's why they have a huge fleet of FPSOs, and they are actually the owner of the biggest fleet, and so they have the biggest number of mooring systems in synthetics. And at an average water depth, it's the biggest by far. Then in 2005, North America, and especially the United States, awake because they have a couple of very rich fields that were on hold because they were blocked with a system with a costly or a commercially costly mooring system to develop that big oil fields that they have beneath. And so in 2005, it was after almost 10 years of studies, because the US Coast Guards and the other entities, before we are authorized, or the operators are authorized to use any elements, any new elements, need to have an approval. And this is an idea for us that writing legislation and experiments and everything, it can take a huge amount of time. And in the United States, it was roughly 8 to 10 years to allow the permission to use the synthetic ropes to moor the platforms in the Gulf of Mexico. So we have several customers there. We have already delivered several projects for Chevron, Anadarko, and also National Oil Well Varco. We also work very tight with the Norwegian markets because we need to be there, because that's where the harsh conditions are. And so if we are trained and if we assess all the conditions from this market, we will be relaxed for the rest of the world. And this is the way that oil and gas industry looks to it. Of course, to be working, operating in the Gulf of Mexico, they have to address to other conditions, but are less severe than in the North Sea. And Eni also, we have a couple of projects with them, one in Norway and the other one in West Africa. What was our idea? It was, since we have our expertise in mooring systems for deep water, and I'm speaking deep water for oil and gas, is not deep water as we are hearing here. So we have to adapt and redesign again more types of ropes tailor-made for each of these families. We separate in wave and tidal energy converters and also in offshore wind farms. And then, of course, there is also some families of different devices that doesn't stay under the previous designations. What we did is, once we have all these mooring systems already applied, which are ropes very large, but the lines are very, very long, so you can accommodate all the differences of the dynamic behavior of the sea conditions and weather conditions. So we have to scale it down for the wave and tidal energy converters. So in this area, it's the opposite. What you want is to have an element of mooring that will not extend, so will not lose any of the movement that the device is trying to catch. So we have to go to a special fibers that nowadays already exists to try to control and to lose as less as possible. So on this project that was supported by the AVE project, this is inside the FP7 European project funding, and two of the main goals of this project, it was to understand the flexibility. Here we have a conductive steel wire rope inside the synthetic rope. The idea is have a kite with a parachute that will make rounds and circles in the air and which will engage to this device that will make the mechanical movement and from them retrieve electricity. So this is already, yes, this is already made. The field experience has finished. It will be all finalized in the end of this year. More devoted for the mooring systems itself, As I explained, we are also using the Marinette structure, which is a European network of infrastructures to test. We develop a hope now to work with wind farms, which is working on a shallow water, or for us, very shallow water, which is the 70 meters and 80 meters of water depth, in order to have the dynamic answer that the floaters will need. So it's another project, that is still also going to finalize at the end of this year. So the buoy was already tested, so now it's only missing the DMAX modeling to extrapolate this data for other projects that might arise. And now the logistic part. You saw MDS referring a little bit some conditions that we need to assess, and one of them is in oil and gas, the main costs that you cannot control is basically, or you cannot control, I mean, you have to have extra careful is what are the costs of the installation? Because the cost of installation, a platform, is several times in a scale to 10 to 20 the cost of the mooring system. So that is a very sensitive plan to take into account in the capex of the installation and the project as it grows. On this area, renewable fields, it will not be the case. The case will be the maintenance and also the time of the operations that you need to take it into these operations. How many, if you save 1 day or 1 hour while you are disengaging the system to take it or to make the operations that they need to make on the maintenance, you are saving lots of dollars because you are the most expensive expenses are in those conditions. So we also develop a new and a quick way of disengaging the mooring legs in order to quickly obtain the device, make the repair and correct it. To finalize, this environment for us, it doesn't present quite some new concepts like the oil and gas industry is working with us. In the last time oil and gas required for our rope construction, it was something that could not be cut by a steel wire rope because the trawlers of the fishing could be cutting the mooring legs. On your area, in renewable areas, what we need to do is to redesign the ropes to absorb the elements or the dynamic and weather conditions imposed by the platform on the mooring system. What we felt, and we just came from in June, there was a OMIE, which is a conference where addressed especially for oceanic and the renewable energy is quite there present. This year, just to make a comment, we saw 600 papers of systems that they were trying on modeling stages to get wind farms, tidal projects for and wave energy converters. A lot of options and technical solutions that need to be proven, but a lot of concepts, which is quite good. But that creates a difficulty for the industry because until it is proven, we should be only concentrated with the things that we know that are more secure, and it will allow us to have a plan and a firm plan with an horizontal of time that can be predictable and can give to this project of renewable energies some profit, some economical reason. To finalize, I think that codes and standards, Portugal is doing a great job compared with other countries. Probably the delay of other countries are also in that area because they want to be very quickly on renewable energy, but when they arrive to the field, but it's needed to define what we need to do, what we can do, and what we cannot. So we found already several experiences that these quick movements will create a stopping point and a lot of frustration for the promoters and also for the governments. And to finalize it, I have just this last slide, which is most of the costs, as I referred before, that can take a comparison with the cost of the mooring system. It concerns to the installation on the oil and gas, but on the renewable energy, it is not that way. It's the maintenance. Because it is not that way because we are not working in a deeper water. But the maintenance will provoke and a lot of days that the engines or the structure will not be working, and also a shorter maintenance period should be defining the life and the profitability and economical of that solution. This should be what we think it's the most important task that sometimes we don't see that being very well taken care on projects, governmental projects as such. So basically this was my inside the logistic. I think it's the greater difficulty and challenge. Well, let's not call it a difficulty, call it a challenge to what we have to do and what we have to face. And thank you.
Again in this conference.
Thank you, Mr. Chairman, António, sponsors of WavEC and staff here for inviting my participation in this, one of the world's great cities. This is my second day here and it's amazing. Bad news is that I'm standing between you and lunch. The good news is that I'm going to talk about fish. So work up an appetite. What I want to talk about, logistics of advancing offshore energy, is a key logistics question is how, as we advance new and emerging ocean uses, like offshore renewable energy, how does this use, this new use in some places, interact or interface with some traditional uses such as commercial fisheries or recreational fisheries, which have been taking place in these similar ocean spaces for generations. And I'm going to share with you a story of work that I've been involved in the United States, in the Northeastern part of the US, which I basically, my caveat is that there's no recommendations that are coming from this. We're just sharing an experience. Some of the solutions that we've come up with to address the interactions between commercial fishing and offshore wind development might be very unique to the Northeast and not applicable in other areas. That said, my takeaway messages, because I'll start with them here, is collaboration is a key element of successful development of offshore wind with other industries. And that collaboration takes the form of government to industry through regulatory frameworks. But what we've found in advancing offshore wind in the Northeast is that industry to industry collaboration, even sometimes with no government at the table, has been a really effective way of addressing some of the potential conflicts between these ocean uses. I'm going to share a case study of a pilot offshore wind farm off of Rhode Island in the Northeast US and talk a little bit about what's happening on the horizon. Real quickly, my name is Andy Lipsky. I work for a nonprofit organization. We were built to advance marine spatial planning in the Northeastern US. We were the private side of a public-private partnership with the Commonwealth of Massachusetts to develop the first ocean plan in US waters. Since that time, we developed ocean data, policy, human use characterization studies, and to help advance good stakeholder engagement and sound science to advance marine planning and marine planning initiatives. So that's the end of my propaganda. We heard earlier today we have a lot of offshore wind energy potential in the US, over 4,000 gigawatts of potential. This is a part of a transatlantic experience, and all of the above energy strategy. We know this is an important thing to do. We want energy, but we also want food too. So how can we do these things together? This is a view of the Northeast Mid-Atlantic regions where large-scale offshore wind energy developments are now being contemplated, planned, and will be built in the coming decade. And a close-up view of southern New England, where I get to work off of the coast of Rhode Island and Massachusetts, shows tremendous wind energy potential, and that's where a lot of offshore wind energy development is currently focused. Let's move forward. So there are logistical constraints. We found in the US, one of the oldest projects that's yet to put steel in the water, the Cape Wind project, was constrained by not in my backyard. There are other reasons for the reason that project hasn't been built yet, but it is moving forward, but it's been over a decade. Marine shipping and transportation, other ocean uses that share that space. Traditional fisheries is the topic of focus here. And of course, there are environmental effects. And we heard from earlier speakers today what some of those impacts might be and the need to understand those impacts as we move to creating a blue economy. It doesn't mean that we do it blindly, thinking that there will not be interactions or impacts with other resources. We're going to talk about fishery resource impacts. Commercial fishing, so big wind energy potential, future new emerging use, but let me go back. Pardon me. This is where commercial fishing takes place off of the Northeast. It's all over, and it's been happening for decades upon decades with tremendous values in terms of the economics, and also satisfying, like Portugal, the US has a significant appetite for seafood. I don't think it's quite as large as your countries. But like Portugal, we also have a major trade deficit, and we can't meet our own, through farmed or wild fisheries, we can't meet our own demand for it. So there's a significant need for us to continue to fish these waters. And fishing, I'm not going to go into sort of the constraints within the industry, but the fishing sectors in the US are very constrained. We have overfished stocks. We have the impacts of climate change. We heard the impacts of ocean acidification with really scary impacts. We've got management regimes that make it so difficult for these women and men to make their living. So anything else added to their plates, like a new ocean use, is right. The immediate reaction is this is a concern for us. Where are we going to go? Some of the interactions that have been, some of these have come out of European studies, and what we have understood from building wind farms in other parts of the world. But the things where we see the interactions are a loss of access to fishing grounds, decreased catchability of fish during and after construction. Again, I'm saying these are possible impacts, not impacts that every project might experience. The loss of gear, we heard that, where you're trawling, if you have laying a cable down and it's not buried deep enough, we could lose gear. Changes in abundance and distribution of key species. Disturbance from noise or EMF. Impossible aggregation effects. So some of these interactions are positive, some of them could be negative. One of the projects that I've been really privileged to work on, because I love working on projects that actually are going to build something, and this is going to advance offshore renewable energy, but also address commercial fisheries interactions, is the Block Island Wind Farm. It's a pilot scale project. It's a 5-turbine, 30 megawatt installation about 18 miles off of the coast of Rhode Island. And the developer is Deepwater Wind LLC, which recently won the auction of developing one of the large wind energy areas off of Rhode Island and Massachusetts. So this is a pilot scale wind farm, and the community, when I say the community, the government and industries, the NGOs, we look at this as a pressure test of how can we think about, plan, permit, and then construct a wind farm, but not just construct it, but live with it after it's constructed. The project was cited through a maritime spatial planning process, one of the few that have occurred in the US, and this is through the Rhode Island Special Area Management Plan. So a lot of data and science went into identifying a renewable energy zone to deconflict the area before we would even contemplate putting any type of wind turbines. Nonetheless, just because we've gone through a maritime spatial planning process doesn't mean there aren't continued to be interactions. So that's really where I was able to interact in the project. Is the Maritime Spatial Plan was finished, the developer was selected, and the developer was moving forward through a regulatory process and a planning process. And one of the things that we did working with Deepwater Wind is establish fishery liaisons. We had a commercial fishing liaison. Some of these are building off of experiences we've seen in other countries, such as the UK or Ireland. And we had a fisheries liaison who was a member of the fishing community that played a vital role in getting information back and forth between the two industries. And we set up a framework for industry-to-industry engagement. So government, and I spent 10 years working for the US federal government, and I love aspects of government life, okay? But sometimes it's good that government isn't invited to the table. And so we created a framework where the two industries could meet at a table, and it wasn't the permitting vice president of the offshore wind developer that was at the table. It was the engineers, the construction managers who know how to build offshore structures, talking with fishermen who spend every day of their lives, or most of them, out in the water. And they understand each other because they both understand how to conduct business out at sea. That broke down a lot of barriers to having a very constructive dialogue. We went through a period of industry-to-industry engagement where we conducted questionnaires and interviews with the industry. I was hired on as a scientific liaison to think about some of the science gaps that were associated with the project. And we had the commercial fishing liaison. And we basically had a number of meetings, and we scheduled these meetings when people weren't out at sea. We went down to the docks and invited fishermen to come to these meetings. And it wasn't just that the developer was clicking the box of, I got to deal with commercial fishing because they could potentially, kill this project in the end. It was more about that industry is out there, I have to share the space with them. Let's think of a proactive way of addressing areas of potential conflict and do it in an objective and transparent manner. We conducted surveys. We did them at times when fishermen were available, which would tend to be scheduling meetings if we knew a big storm event was coming on where people weren't going out at sea, and we know folks would be around. We did them in the evenings. And we did interviews, and then we reported back out to the community, and this is what we heard, what their concerns were. We developed a framework for basically dealing with those concerns. Some of those concerns were, well, what's going to happen to us financially? Are we going to be displaced during the construction period? Oh, it's only going to be temporary, and you're only going to close this area for a short period of time while the derrick barges are out? Okay, we can live with that. But what's going to happen to the fisheries? By the way, there's no U.S. studies ever conducted on building an offshore wind farm, and you're going to do it, and it might have a positive impact, might have no impact, or might have a negative impact on the species that we care about. So it'd be great if we had some collaborative science that went along with this. That was part of the agreements that we developed between the two industries. And we also looked at one of the big issues is the fishing community's capacity to even come to the table. They're out at sea trying to earn a living. They come to the table, no one's paying them to come to the table. And so anytime lost fishing is lost income. 2 minutes, great. And so one of the mitigation requirements or agreements that came into place for this was funding basically a position for a nonprofit commercial fishing non-governmental organization. And basically the industry controls who that person is, and that person can interface with the company as we think about direct or indirect mitigation, and be there to represent the fishing industry. And then developing agreements. One of the key things that we've done is implement collaborative data collection. So we sat down with fishermen and the wind energy developer to really get at what are the key questions the industry really cares about. What are the places or the species that they're most concerned with? And design study protocols that reflect the questions, not necessarily reflect questions that the research community has about fisheries, but reflect the questions that the fishing industry has, and also reflect their concern on how the data is collected. In the US, we have significant issues between government data, managing fisheries, and the data is entrusted. So we created a framework where we brought the fishing community, traditional knowledge and expertise in around the table with our statisticians and fishery scientists to come up with protocols to implement cooperative studies, long-term studies to look at what happens to key fisheries, groundfish and lobster, before construction, during construction, and after construction. And what was really interesting, so this is just a location of where some of our trawl surveys, and what we found is that if the scientists just sat in the room and created a protocol that looked great and had power and it was robust, and then we would bring it to the fishing community like, yeah, you can't implement those trawls because the bottom, even though you might have side scan sonar and bottom profiling, you can't trawl there. So if you're going to do a 5-year study and go out and trawl every month, you're going to have to figure out a different protocol. So we use that local and traditional expert knowledge to help even improve the methodologies we employed for these studies. We have an American lobster study and a groundfish study. Those are the big studies that are underway right now. Every month of the year, we're going out on a commercial fishing boat, fishing the same net, fishing the same boat with a leader in that fleet, so that when we come back and report out, as we do every year, the fishing community trusts that data because they know that data is being collected by fishermen. So the key lessons learned or next steps is integrated marine planning doesn't end when you have a plan, and that the concepts of transparency, identifying where your data gaps are and filling them, involving stakeholders, particularly industries that are most affected early on, are a great part of implementing these projects. And they save costs in the end. Before we started working on this project, after the plan was done, the fishing industry was braced to take this project to court. Even though we had a very robust planning process in place, there were those in it that it was just another thing they would have to deal with. About 6 months ago, the final hearing for the project, we had a member of the Fisheries Advisory Board, who's a commercial lobsterman, stand up and say, we want you to permit this project. We want it to go in because it represents a collaboration. And we're really worried about what happens when we go full scale and develop hundreds of wind turbines in areas that are very productive. And so the relationships we build between the two industries and filling these knowledge gaps are going to really help for constructive conversations and engagement when we go to full scale. And I think that filling the data gaps in the science, involving their traditional knowledge and expertise went a long way to maybe turning the tide and bringing those two industries together. Just on the horizon, we'll be building the Block Island wind farm, steel in the water. All the permits are in, all the money's raised, the financials are done, and next summer they'll begin construction of the project. I think I have just one slide. This is one of the two big wind energy areas off of Massachusetts and Rhode Island that are being contemplated. Originally, the area that I have dotted in red was a part of the wind energy area, but because of very proactive interactions between the two industries, they realized this middle area, which was now cut out of the wind energy area, was a vital area for squid and scallop. I mean, tens of millions of dollars being generated in those areas. Bringing the industries together and having those relationships allow these types of conversations and decisions to be made so that we can move forward and develop our offshore energy resources, but we can still obtain and eat the seafood that we all love and need. Thank you.